big full room indeed. Thank you all for being here. So I will talk to you about agents beyond the prototype. A quick introduction. I'm Victor van der Broek. I'm a senior solutions architect at Databricks. I have about 2 decades of experience in data and AI, and I typically focus on public sector, sovereignty, generative AI. And for those of you who do not know Databricks, we offer a cloud platform for data and AI. Pretty big right now, over 20,000 customers, 4 billion in annual revenue, and 1 billion of that is actually in AI. So, given the crowd in this room, I'm sure you've all seen the agent hype everywhere. Articles saying, hey, we have labor force displacement, can we build billion-dollar companies using agents, they will do the grunt work of coding. And at the same time, you also get the negative press, the other side of the medallion, saying we have a lot of pilots and we don't get them to production, and it's like we're not proving the value, and like how do we marry these two facts? Well, first off, agentic AI can be very successful and productive, and we've all seen these startups on the coding side, things like Cursor, Windsurf, Lovable, all of whom have accelerated the vibe coding era and generating also a lot of revenue, a lot of value for their customers. On a somewhat smaller scale, Databricks itself, we've also launched agents that actually perform work for you. We have a data science agent that explores data for you, creates hypotheses, exploratory reports, and so on. So these are successful, but what sets these apart from the problems we've seen with agents on the other side? Well, on the one hand, code is unambiguous, right? These agents, they write code, and in the end, that is unambiguous. It's 100% verifiable as correct or incorrect for what you are doing, and they're keeping the human in the loop for fast feedback cycles. If you want to move beyond that, and you want to move beyond code towards the ambiguous side of things, where we're talking about English language, this poses some new challenges. We see that as that the generic models, the ones you all know and probably use every day, they fail for once you get to enterprise use cases. So they do not necessarily understand your context, your data, your problems. You need to train them or feed them that as well. So how do you actually connect all of these models to your specific data? Now, once you get into being able to connect that and you start moving towards an agentic AI framework, first let's see what does an agent actually do, right? So again, you probably have some knowledge about this. You send a prompt to an agent. That agent then goes off and does all kinds of things on your behalf. We have a customer service agent here that's basically being asked, can you help me return my last order? Then that agent reasons what to do. Out of this question, can I get your last order? Do I know who you are as a customer? What are the return policies? It starts fetching all these information and compiling that into, in the end, here, this is done. Here's your shipping label, just slap it on and send back your product. That was an agent. So what do we see as common agent design patterns in our market, and also ones that we've built ourselves? So the most useful one, or at least the one that most people use at the moment, are agents with documents. So RAG chatbots. You have some documents, you chunk them, you put a vector embedding on top of it, a model on top of that, and you start interrogating your data. So agents with documents, that's one. Next step, agents with tables. So you have some structured data, and you want to start interrogating the data itself. Right? These are text-to-SQL type of agents. Next step in that curve is, okay, let's start putting some more tools in place, like have these agents actually be able to perform something, right? Create a shipping label, update some information, for example. These become the tool calling agents. Then the next pattern that we see is agents that are actually orchestrating other agents. So they're intermediary between several different agents and actually start calling them as and when needed. So by now, all of these patterns can be procured as a service from the different vendors as well. Once you start building these agentic systems, you move through a maturity curve. And this is where the experiment, you've probably all done that. Then you get into the prototyping. It's like, yeah, this like we have something, we're able to prove some value, but you make the chasm once you start going to deploying and scaling. That becomes usually the part where there's a lot of questions from the organization. Is it safe? Can we do this? Is this okay at scale, yes or no? And that's why you need to properly implement your governance as well. So in the technical development, you have things like development environment, test and production, etc. But this is all very much focused on creating technically a model that works. You also need to look at, yes, but once you are in that production situation, how do you monitor things like quality, and how do you make sure that people are actually seeing the data that they are allowed to see? So that is what we see as well, right? There is these steps of preparing data, building agents, deploying agents, and evaluating them as well. And all of these have different subsets that help you govern the use of these agents. On top of that, you still need things like AI guardrails or usage tracking or rate limits to prevent abuse. The guardrails can be there to say, hey, in the end, just check the output of what you're trying to send to a customer. Is this something that you find okay, yes or no? And you can get different agents and models evaluating each other as well. So these are all things that you can use to build an agent. And that's where we get into the more complicated, but also the more valuable part of the agentic frameworks. So beyond the single agent, what we saw at first is that you have like all these departments and they're trying agentic AI because, you know, there's a lot of value and we need to do that. What do we see in the end? We see an engineering department taking all its product documents and it builds a troubleshooting assistant. A supply chain builds an inventory expert agent. Customer service builds its own agent. Suddenly, you have 3 different silos, 3 different realities, and they're not talking to each other, right? But this supply chain agent, if you have a customer service, that should be able to ask that supply chain agent, how are we doing for stock on a particular item? These should be able to talk to each other. And you know, there's a lot of like protocols being developed with MCP and agent to agent and so on to make this more a reality. But you still need to look at, okay, but how are you actually going to use that? How are you going to scale that beyond just having that one particular agent as well? Because that's placed, and then you have 2 paradigms. The first one is getting to an agent chain system where you're saying, okay, you have this user and has this first agent talking to that user. It could be, hey, who's the customer? What's your product? What are the things that you are seeing? And these start going back and forth between each other and saying, hey, I need to troubleshoot something. Maybe I need more information from the user, and they go back and forth. So this is where it starts to get hairy, right? Because you have different agents that will have different contexts and might know different things about your users as well. Like you do not suddenly want an agent replying to a different user or querying maybe information that's sensitive for someone else. So part of what you need to tackle once you go beyond the single agent as well is tracking state with the interaction of the user. The first thing pretty much anyone does when you do that is you stuff everything into the prompt. You're saying, hey, these are interactions I had before with this user, these are answers I got, and like your prompt starts getting bigger and bigger and bigger. That's also typically where these models start, having more trouble, start hallucinating a bit as well. So that's annoying to get to track state in a prompt. Instead, what we see for successful agentic deployments is they start storing state in a fleeting database, for example, or storing it in files, at least somewhere where it's persistent compared to a prompt that you're feeding the model. So a next agent could say, okay, I have this user, track the state, do something, store that state. And they disconnect from the prompt in that way. We also see that in the market. So a while back we bought a startup called Neon, and why did we do that? Well, one of the things we saw is they are for hosted Postgres, but the amount of databases that were being created on their platform, it both exploded, but more importantly, end of last year, about 30% of the databases created with Neon were made by AI agents, and half a year later, it's 80%, and this is still growing massively. So smart agents tracking state, they store that in a persistent data layer. This also opens up, again, governance questions, right? How do you make sure that the agents are able to query these databases and get back the correct state as well? Now, if you successfully implement governance around these agents, governance around the tools, governance around the servers, governance around the models, you get a bit what you see here, and that is a lot of communication back and forth, and basically you're creating an organization of agents and protocols talking to each other, and the only way you're going to actually properly manage the outcomes of that is put things in place like inference tables, LLMs judging output as well, have a human in the loop for like special circumstances as well, and you need to treat that like an organization that you're managing and governing on its own. So these ecosystems start expanding more and more, and you need to think of your agents once you go from those first prototyping beyond your own organizational limits to, okay, what do I expect a user of this system, whether that user is a human or that user is an agent, to be? What is he allowed to do? What are responses that I think are okay? How do I verify that these outputs are okay as well? So once you get into that multi-agent system, you need to start thinking of both some technological aspects that are essential and some organizational aspects that are essential. So you need to think about authentication, both machine to machine and user to machine, who's whom, and how do you make sure that they can properly interact with all the components that are in your agentic system. An example, you do not want an agent to have its own credentials to create that database. If it doesn't know who that user is, and I can actually put pass through an identity like that, you do not know exactly what policies are being applied on a database level. So those are typical things where you want to push down users and identities as much as you want throughout such a chain. You want to define these governance and access controls both around the data, the models, and the agents as well. And of course, you need to do things like manage infrastructure, containers, versions, and all those things. Those are a bit more on the technical side, but you still need to understand the impact of technical changes on the functional side as well. What does a model change mean, right? So if you've developed an agent, for example, on a GPT-4 model, and a new model is released by OpenAI, what does that do? How do you make sure you can control the quality and think of it in that way? So if we look at that, like unified governance across your agentic estate and across different agents and organizations as well, those are essential to making your AI agents scale beyond that prototype stage towards a production stage, that you actually, as an organization, feel in control. Because technically there's a lot possible, but usually we see that things like risk management, cost management, etc., that those are blocking when moving beyond that prototype stage. Of course, you can do all of this on Databricks today, and yeah, that leaves still room for some questions, I think. Of course, if at the end there's even more questions, there is a booth where I'll be this afternoon as well. But this was it for me. Hopefully we still have some questions in the room as well.